Hey everyone, so the last unit we're going to do this year is over conic sections. It's a short unit, there's only 3 lessons, um, but they're very long. And so this is where the benefit of flipping the classroom comes from, because these notes would actually take probably at least 2 days to do in class. So again, they're a little lengthy, so bear with me. Not overly complicated. It's formulas and looking at relationships between values and stuff like that. The first conic that we're going to look at is parabolas, and I know we've done quadratics and parabolas already, but we're going to look at how to graph and construct a conic section, and that's the most basic one. And so we want to start with that. But some new terms we're going to introduce here are vertex and directrix, as well as focus of a parabola. So before, when we talked about parabolas, we didn't talk about those. So we're going to introduce those terms, and then use that information to be able to construct it. So we're not just going to look at your basic parabola that's open up this way and open down. We'll also look at sideways ones where we have y squared and how to determine all of that. So we can take any point on a parabola, so like this point here, say, and the distance from it to the directrix, which is a fixed line. So this is your directrix down here. So this distance here, from here to here, will be the same as the distance from this focus point to that same point. So these distances are the same. Those tick marks, hopefully you remember from geometry. And that works for anywhere on this. So you might go ahead and fill those lines in. I know, like, I don't think they copied very well. So any point on your parabola works the same way. So here to here would be the same. Your axis of symmetry is still right down the middle, so it's going to not only go through your vertex, but also your focus, and then it's going to be perpendicular to that directrix. And again, the vertex is that point halfway on your parabola where it like changes directions, your turning point. So it's also halfway between your focus and your directrix. So this distance here is the same as this distance here. It's a midpoint. Okay, so getting all those basic definitions out of the way, we're going to look first at an unshifted parabola. And so keep in mind, oops, what's going on here? Keep in mind, as always, that this is your parent function. So we're starting with our vertex at 0, 0. And then this would be true of all of those. So if it's going up or down, you have y equals ax squared. Those should look the most familiar to you because those are the ones we've done before. So you'll have 2 scenarios. Right? Again, this part shouldn't be new to you, where we have a is greater than 0, which means that our graph will be open up and go through 0, 0 at the vertex. But then it will have this point here, your focus, and your focus, we're going to say, is at 0p, where p well, let's rewrite this. The vertex will be p spots away from the focus and directrix. So we'll call that point 0p. So again, unshifted 0p. It won't always be that. Which also means that that same distance away down here, it's not straight, we will have a line at y equals negative p. So shifted that same distance. So this would be 0, negative p, this point here that passes through below your parabola. Okay, so this is when it is open up because a is greater than 0, and you have those 2 points. Okay, so then you can also have when a is less than 0, so this is when it's open down, right? So we have your upside down parabola. You're still going to have, we'll do the same color here, your focus. But this time, that focus will be at 0, negative p, because we've flipped it. So your focus will always be the same direction, and this will be at y equals p. Sorry. Your focus will always be the same direction as the opening of your parabola. Okay, so again, those are the parabolas we've seen before. We're just adding in that directrix and that focus. Okay, so you can also get x equals to y squared, and when this happens, you're going to get a sideways parabola. So let's go ahead and look at when a is greater than 0. You think about this will be positive, so it's going to go in the positive direction. So it's going to be open to the right. Okay, this, again, isn't shifted any. But that means that our focus will be here at P0. So this time we're moving to the right. So our x goes to the positive direction. And our directrix, instead of y equals, will be x equals. X equals negative p for your directrix. If a is less than 0, we're going to just flip that over our y-axis this time instead of our x-axis. So it will be open this direction. Again, with that vertex at 0, 0. And we'll have our focus then on the left side of that. So your focus would fall here. At negative p0. And then your directrix will be on the positive side, x equals p. Alright, so just keeping in mind that these are inverted and that your x's and your y's are flipping around there in terms of your focus and your directrix. Right. In all cases, so no matter what, so this is a formula you're really going to want to know, a is equal to 1 over 4p. P is the directed distance from the vertex to the focus. It's always that distance in between those two. So it's really helpful if we can find P. And we can always find P by looking at the equation and knowing A. This would also work the other way. So that's just a formula you'll need to know, and we'll use in just a second in an example. First, let's just kind of summarize this one more time so that when we do an example, we can know just by looking at the equation what we're looking at. So up here, when you have y equals x squared, the vertex is going to be 0, 0. The focus will be 0, equal sign. The focus will be 0p. And really, even on this side over here, where I wrote negative p, we think of it as p, and we'll think of this as the opposite, because what you'll find is that your p ends up being negative. And so when you plug that in, it changes this to a positive. So you'll kind of see those in the examples. Your directrix is y equals the opposite of p. Okay, and then down here we have the vertex is at 0. If the vertex is at 0, 0, the focus is at p0. So notice our x's and y's changing sides. And the directrix is at, I should use colons here, x equals the opposite of p. Okay. So let's look at a couple examples of that. Remember that your vertex is hk. That has not changed. So when we're looking at transformations, it's always hk. It doesn't matter if it's y equals or x equals. But what you will see is that your h is always grouped with the x. Your k is always with the y. So like you could subtract the k over and it would be with the y. Here, k is with y, x and h would go together if we moved that h over to the other side. So look carefully at what variable is being squared and know that k goes with y, x goes with h. This information up here is the same no matter what. Okay, moving into some examples, you'll look at an equation. First, determine which way it's open. So we have an x squared, so we know that this one is open up, or opens upward, however you want to say that. Our a value is positive, so that's how I know it's up instead of down. So remember that a is equal to 1 over 4p. So 1/8, this is your a value. So 1/8 is equal to 1 over 4p. So we're just going to cross multiply here. So 8 is equal to 4p, and p is equal to 2. So what that means is that the focus will be 2 above the vertex because it's open up, right? So it goes up. And the directrix oops, I just didn't even, let's try that again. Directrix will be 2 below the vertex. Oh my goodness. There we go. Your vertex is hk. So your vertex is at 2, 3. Remember to watch your signs. So here's your h, here's your k. So you think about above or below, those are y values. So when we're talking about above or below our vertex, we're going to look at the y value, and that point is going to change. So without even graphing it, I can say, okay, well then my focus is going to be the same x value. That's not going to change, but it's going to go up 2 from 3. If I go up 2 from 3, I'm at 5. And my directrix goes down 2 from 3, and it's a line, so down 2 is at 1, which means it's at the line y equals 1. Let's look at a visual of that, so maybe you can see that a little bit better. This parabola is open up from the point 2, 3, so we'll start by plotting our vertex. So here's our vertex here. It's 1/8, which means it's going to be fairly wide, but these are really just really rough sketches. So here's your vertex. Okay. So if I go up 2 from that point, this is your focus, and you can see that point there is 2, 5. If I go down 2, so here's your P in here. If I go down 2, go that same P, then I'm at this line here that passes through that, which is the line y equals 1, okay, which is your directrix. All right, and so that's it for that one. Let's look at one that is x equals something squared. So we have x equals, so y is being squared. So we look at the sign on our a. A is less than 0. It's a negative value, so this particular function is open to the left. And if you forget that, because your graphing calculator won't graph these, if you forget that, just think about the fact that x is equal to a negative number. Where is x going to be negative? So it's open left. Because of that, this is your k, and this is your h. So keep that in mind. Your vertex is at negative 1, 2. Where that goes there, and that goes there. Okay. A is equal to 1 over 4p. We do want to start with that. We need to find what our p value would be. So negative 1/2 is equal to 1 over 4p. Assign the negative to one of them. It doesn't really matter. I'll usually take it with the whole number value, so that I have 4p equals negative 2 and p equals negative. Yeah. P equals negative 1/2. Okay. So a little bit harder to graph, but that means that the focus will go 1/2 left. All right, you don't need to put negative 1/2 because you're not going to be moving negative in the left direction. That left takes care of it. 1/2 left of, I'm just going to put V for vertex, and the directrix will go 1/2 right of V. Okay, so if you have trouble coming up with those points before you graph it, then just sketch your graph first. That is fine. Color I used here. Let's purple again. So we have our line open. Oh, what am I doing? Forgot to plot the vertex. So we have our vertex at -1, +2. So here, that was, let's try that one more time. Do your best, please. And so, again, that's your vertex. So we're going to go for our focus 1/2 away. So if that's at -1, that's -2. We don't want to go all the way to -2. So there's our focus. And then our directrix, same thing. We're just going to go 1/2 this way. And so this would be x equals -1/2. This point here is your focus. And you can see it's at -1.5, 2. So negative, I'm going to put 3/2, 2. Right? Okay, so I'm going to get you started on this one, but then I'm going to have you pause the video and try it yourself. So the only difference with this one is that we don't have a variable equal to itself, so you need to solve. All right. So look at what variable is squared, and in this particular case, it is your y, which means that this will be an x equals. Okay, so this one will be open, either left or right, yet to be determined. So we have y plus 1 squared is equal to 16 times x minus 3. And again, your goal is to get this x by itself. Okay. Oops, sorry. X minus 3. So the first thing I'm going to do is just divide by 16 on both sides. But when you write that, you're going to put 1/16 times y plus 1 squared, because that has now become your a value. And that shouldn't change. So equals x minus 3. So then we're just going to add 3 to both sides. And so we end up with 1/16 y plus 1 squared plus 3 is equal to x. So now we have our x by itself. Go ahead and pause the video, and I want you to go through the steps that we did up here. Describe the opening, find your P, your focus and directrix, and sketch a graph. Okay, go ahead and check your answer here. P was 4, which means we're going to go right and left. This is going to affect the x value, so if you're finding your points and equations before you actually graph, you're adding 4 because you're going right, and then you're subtracting 4 from your x values. So open right, down. Okay. All right. This is where our good friend completing the square comes back into play. So a lot of the things that we learn cycle back into another lesson. Hopefully you'll see that as you continue on in your math careers, that not all of this was for naught. So again, we have x squared, which means that we need this one to say y equals. So we need to get the y by itself. Okay, so remember C is equal to B over 2 squared, but also that we're not going to have that lead coefficient. So we're going to have to rearrange some stuff in this equation before we can go through this process. So the first thing I do is move anything that is not x related to the other side. So minus y minus 5. So 2x squared minus 4x equals negative y minus 5. And then we need to get, again, rid of that lead coefficient. So we're going to divide everything here by 2. So this side as well by 2. So now we have x squared minus 4x. And I'm going to put plus, and we're going to put that space there. This is where we're going to fill C, and negative y minus 5 over 2. Or it actually might be better. Let's do this. Negative y over 2 minus 5 over 2. Because remember, then we're going to add C to that side as well. Let's do that in a different color. All right, so C is B divided by 2 squared. So now our B term, I did not divide that. Sorry about that. Our B term is 2. So we're going to take C equals negative 2 divided by 2 squared is 1. So we're going to add 1 to both sides. And remember, the reason that we do this is that this will now factor into x minus 1 squared. If you don't know how I got from there to there, please refer to your previous notes on completing the square. So this is equal to negative, I'm going to write this as 1/2 y sorry, I had to pause. I had some disruptions. I'm not sure where I was, but this would be minus 3 over 2, 5 halves plus 2 halves, essentially. And again, our goal is to get y equals. So we want this to say y equals something, right? So let's see here. We can essentially multiply both sides. Let me do a different color. Let's multiply both sides by negative 2. And that'll get rid of the fractions altogether. So now we have negative 2 times x minus 1 squared is equal to y plus 3, and then we'll subtract the 3. So negative 2 times x minus 1 squared minus 3 equals y. This example is getting a little long, so here's where I'm going to pause it. I want you to go ahead and break that down and do the sketch. So find your focus directrix, your p-value, and all of that. Okay, so here's what that would look like, up and down. Vertex is your HK again. Solve for p, it's a fraction. So up, down, we're affecting the y value of our vertex. So you're taking negative 3 plus 1/8, and you're taking negative 3 minus 1/8. to get these values. Okay. And then this last one, same thing. We need to isolate x, so that's where you start. So go ahead and try this one on your own. Keep in mind if there's no h or k, then your vertex follows a specific pattern. You should be able to find that point. Okay, here's your solution. Hopefully you were able to see that the vertex was 0, 0. There's a couple different ways you could go about solving this for y. You could subtract x squared and then divide by y. Same result. You get negative 3 for p. Again, p is negative because we're going down, because it's open down. So sometimes the sign can get a little confusing, but it should match the direction that it's open. So p will be positive if it's open up or right. It should be negative if it's open down or left. I warned you these notes would be long. We have a couple more examples. Same thing here with number 6 as far as your vertex, but go ahead and try this one on your own as well. Okay, and here's this one. Hopefully that wasn't too hard for you. It's really just establishing those steps as to what you need to do. So looking at your a value, identifying your vertex. If there's nothing being added or subtracted, it should be 0, 0. Finding that p, which tells you where your focus and directrix are, and sketching your graph. So using all of those, we want to be able to find the equation of a parabola. So if we can establish what our a is and what our vertex is, then we have our equation. So remember, y is equal to a times x minus h squared plus k, or x is equal to a times y minus k squared plus h. So it's going to be one of these scenarios when you're writing equations. This one is open to the right. So a couple things we already know is that this will be x equals. We also know that a is positive because it's open right. And that's it so far. So what we do need to be able to do, oh wait, we know our vertex is at 0, 0. So we can see that. So if you remember earlier, I talked about how your vertex and that axis of symmetry is perpendicular to the directrix. So we're able to then have this square region down here. And this one tells us the area of the square is 16. So the space inside the square here is 16. Well, you find area of a square, if you remember, area is equal to the side length squared. So 16 is equal to s squared. So s is equal to 4. We don't need plus or minus here, because what that tells us is that this distance right here is 4, which means that this p distance up here would also be 4. So if we're going from 0, 0 and we're moving right 4, I'm going to put 4 instead of p, then our focus is at that point 4, 0. Remember, look back at your very first page, p 0, and our directrix is x equals the opposite of p, so negative 4. Okay. Our a value, got a little sidetracked there. We don't really need to find those. But a is equal to 1 over 4p. Well, we know that p equals 4. So we just plug in. So a is equal to 1 over 4 times 4, which is 1 over 16. So we have our h, our k, and our a. So now we just write our equation. So x equals 1 over 16 y, our vertex is 0, 0, so we just need y squared. No addition, subtraction when your vertex is 0, 0. And that's it for that one. And then last problem for today. Tomorrow's notes are just as long. We're going to find an equation for a parabola that satisfies this. So we have a focus at 3, 5 and a directrix at y equals 2. I highly recommend plotting these on a graph. So we have our focus is at 3, 5, which is your F, and your directrix is at y equals 2. So this distance here, I'm going to do purple like I have been, from your focus to your directrix goes from 5 to 2, which is 3. So remember, again, that your vertex is halfway between those. So halfway between 5 and 3, or halfway between, or half of 3 is 1.5. So 1.5 up from y equals 2. So your vertex will be at, the x will be the same. It's going to be right along this axis of symmetry. Up from 2 is 3.5. Let's write that as 7/2. Okay, so my vertex will be somewhere in here. This one is going to be open up. I know that because my focus needs to lie above my parabola and my directrix needs to lie below it. So this helps you know which direction it goes. Let's see, what else do we know? We know that P is 3. Oh, sorry, is 3 over 2. Because that's how far the vertex is away. So A is equal to 1 over 4 times P. So we plug that in. So A equals 1 over 4 times 3 over 2. And that goes to 2. So 1 over 6. And then we have everything we need to write our equation. This is open up, so it should be an x squared equation, which means it's y equals, out of our two choices. So we have y equals 1/6 times x minus 3 y squared plus k, and there you go. So the arithmetic itself isn't hard, but it's memorizing all of the components of that problem. All right, see you next lesson.